All right, so we're going to talk about the polar coordinate system. So it's a different type of graphing. It's just on a different coordinate plane because it's a different coordinate system. We could graph the exact same functions on a rectangular coordinate system as we could in a polar coordinate system. Our equations would look different. There's different reasons why you would want to use the two. Sometimes whatever you're trying to graph, it may be easier to graph it in polar than it is in rectangular and vice versa. Right? So today we're just going to focus on being able to plot some points on the polar coordinate system and figure out where some points are. So before we talk about this stuff up here, if you look at the middle here, here's your rectangular coordinate system that you're used to. We should be like experts at. And then this is what a polar coordinate grid looks like. And it's concentric circles instead of being a rectangle. All right? So let's talk about it a little bit, how we get these points, and then we'll do a few of those examples. So it says up until now, you have graphed on a rectangular plane. That's what we're used to with x and y axis. We will now look at another system called the polar coordinate system. Right? So here's how you get the system. You fix a point O, here's point O, called the pole. Okay, so we can call it the pole, or we can call it the origin, but we really refer to it as the pole most of the time. But it's like the origin is for your rectangular coordinate system. Then from point O, we construct an initial ray. So here's our initial ray that we get. That's called the polar axis. So instead of having an x and y axis that intersect perpendicularly, you only have basically half of one of those. You just have a ray, kind of like the positive x-axis. That's like the only part you got. Then each point P, so here's a point on my polar coordinate system. It's assigned a polar coordinate, and notice this is r comma theta. Instead of x, y, it's r theta. So just like in an ordered pair for your rectangular system, x always comes first, y always comes second. Here, r always comes first, theta always comes second. So r is the directed distance, should sound familiar if you were in AP Physics, from O to P. So this distance from point O to point P, this right here, this is r. So we're not really plotting a line segment, we're only plotting this point, but this distance right here, that's your r. It's like the radius of the circle that you would draw. And then theta is the counterclockwise directed angle formed by the polar axis, and this should be line segment OP, so it should have a little line segment above it. So here's theta. It's the angle that you would rotate around. And we're rotating, you can just think about this, think about like rotating around your unit circle. It's the same concept, it's just not necessarily a unit circle, okay? So if r is negative, so when r is negative, we graph the point positive r, theta plus pi. Okay. So one thing I want you to understand is our coordinates may look different in the two, but I could literally graph the exact same thing. So these 2 points that we have down here, if I was able to, and I tried, but my graphic skills weren't good enough, and I couldn't get these the exact same size, but if I could overlap these 2 graphs, okay, that point, that red point there, it would plot right on top of itself, okay, because that's the exact same, it's in the exact same position. That's all you're doing, you're plotting points, right? It's a position, like telling you how to get somewhere on a map. So it's in the exact same spot, but the ordered pairs clearly are very different. If we graph this in a rectangular system, the point 0, 3, because I don't go left or right any, but I go up 3, make my point, right? In the polar coordinate system, I start here, remember this is my polar axis. If I have 3 comma pi halves, I'd go out to 3, and then I'd rotate pi halves and make my point. So it's just 2 different ways to get to the exact same spot. Make sense? All right, so let's look at another point. Let's look at the point 2, 2. Okay, that's a super easy one to graph in the rectangular coordinate system, right? I can go to 2, 2, boom. Should be like super easy for us. And then we know, because we've been graphing forever, means I go to the right 2, and I go up 2, right? If I connect the origin to that point, I make a little right triangle. What kind of right triangle is that? Close. Isosceles. I think that's what you meant, but yeah, isosceles. So these two are the same, so it's an isosceles right triangle, which means what does this angle right here have to be? 45. Okay, so I'm going to put it in radians. We're going to make it pi fourths, but it's a 45, 45, 90 triangle, right? Which means it's a special right triangle, which means the length of that hypotenuse is a piece of cake also, because if this is 2 and this is 2, this is 2 square roots of 2. Make sense? Like, that's old business from special right triangles. If I want to get this exact same point on this grid, I don't get to go 2, 2. That doesn't make sense on a grid. Instead, remember that r is the distance from the origin to the point, so that distance is 2 square root of 2. And then if I start here, I would just have to rotate pi fourths. So my ordered pair would be 2 square root of 2, comma pi fourths. So 2 square root of 2, with a decimal, it's like 2.8 something. So if I go about to 2.8 something, right about there, and then I rotate pi fourths, my point would be right there. And you can see those would be in the exact same spot. Now, which one's easier, rectangular or polar? Matter of opinion, but I think that we could agree on this one. Way easier to get this point in rectangular because we don't have to worry about the weird numbers, right? But one of the reasons we like polar is because sometimes the numbers are weird and rectangular and nice and pretty in polar. Okay, and it just depends on what we're doing. So we're not converting from one to the other right now. We're not doing anything like that. I just wanted to show you that same point, just 2 completely different coordinates because it's 2 completely different systems, all right? So let's look at how we're going to graph these, what happens when we have negatives and whatnot. Are there any questions right now? Yes, sir. Yes, because it was 45. I just put it in radians, yes. Anything else? Okay. So let's graph these. Well, the first thing before we graph, I want to look at this unit circle that we have here. And we know that we've got pi 6, pi thirds, pi halves, and so forth and so on. So one of them that we usually have labeled is missing from right here. What would go right there? Pi fourths. Okay. So not only was that one missing from being labeled, but you've got some extra lines in here. Because if you notice, it's all done evenly. They're sectioned out into the exact same little sizes, right? So if this is pi 6, then this right here is half of it. Would you agree with that? And half of pi 6 would be pi 12ths. Okay, pi 12ths is not anything we've talked about yet. I mean, it might have come up in something, but you're not expected to know the special values of it. Like you're not expected to know the cosine of pi 12ths or the sine of pi 12ths. No, nobody expects you to do that. But if you have to find a pi 12ths angle on your graph, then you should be able to do that. If you think about the way we counted around things. So like if I said 5 pi 12ths, where's that angle? Well, if this is marked off in pi 12ths, wouldn't this be 1, 2 pi 12ths, 3 pi 12ths, 4 pi 12ths? This would be 5 pi 12ths. Make sense? So if pi 12ths comes up, don't tell me you can't figure it out at all. You know enough about the unit circle, you can figure out where it is, okay? Just think about the same way you've counted everything else around there. All right, so let's start plotting. Let's look at number 1. So we've got point A. It's at 2, 7 pi 6. So I go to 2 on my polar axis. Then I'm going to rotate around to 7 pi 6. That's in the 3rd quadrant, plus it's actually labeled. It may not always be labeled, but you should be able to figure it out. So 2, rotate around to 7 pi 6. There's my point. That's point A. Okay. So usually I go to the number 2, and then I'll rotate around, and then once I get there, I double check that I'm still on the correct circle, in case your hand slips off or something. But any questions on how I got A? All right, then you try and graph B. I'll give you a second to do it on your own, and then I'll do it. Make sure we can get this done right. Okay, so since it's 0.5, 3 pi fourths, this is 1, so here's 0.5. I'm going to rotate around to 3 pi fourths. 3 pi fourths is in the 2nd quadrant, so I get right here. That's my point. That's point B. Everybody agree with that? Any questions at all? All right. So number 3. We've got a negative pi thirds. What do you think that means? We go clockwise, right? So positive 3, I go to 3, and instead of rotating counterclockwise, it's a negative pi thirds. So I rotate here, and this is point C. Okay. Everybody good with all that? Okay, so now we have a negative radius. So what we wrote up there is that if r is negative, then what we're actually going to graph is the positive r and then the angle plus pi. Okay, so pi force plus pi is 5 pi force, but you don't even have to do those calculations, and I'll show you why. So if I go to 1, and then I'm going to go to pi force, which is right here, but I'm not putting a point there because I have to add pi to that. Well, if I add pi to that, that basically means I'm rotating 180 degrees, right? So instead of being in the first quadrant, I'd rotate around and I'd be in the third quadrant. Make sense? So a different way to get there, here's what I'm going to do. I'm going to go to 1 pi force. I'm going to put a star here. That's not really my point. And then when I rotate around, I actually end up here. That's where I actually end up. But I'm going to show you a way that we're going to do it where you're not having to rotate another pi. So what happens is, since this was on pi force, obviously this is on a pi force angle here, right? Just goes straight through the circle because it was half of it because it was pi or 180 degrees. So if you do this, excuse me, when we do this, if you go to 1 and then you go to pi fourths, since the radius is negative, pass through the pole and end up on the other side, that's how you get that point. Does that make sense? It's a little easier than rotating. We good with that? All right, so then you try number 5. You don't have to put the star when you do it, by the way. I just did that so you'd see where I was. Okay, so I would go to 2.5, rotate around to 4 pi thirds, which is right here. But since the radius is negative, I don't leave my point there. I pass through the pole and end up over here, and that's point E. Do you agree with that? Any questions at all? Yeah. When you have to go through? Only if it's negative. So always go to whatever the number is and rotate to whatever it says. If it's positive, you put a point there. If it's negative, you pass through the pole. Okay? That's a good question. Anything else? All right. Y'all go ahead and try number 6 then. We got a negative radius and a negative angle. I think you can handle it. Okay, so I'm going to go to 3. I rotate negative pi 6, which puts me right here. I'm not putting a point there, though, because I have a negative radius, so I pass through the pole and end up over here, and this is point F. We good? Okay, so let's talk about point F before we move on to the next part. This is what we just plotted to get there. But there are different coordinates that I could use to get right there. Like instead of using negative 3, negative pi 6, I could have used a positive 3 and a positive 5 pi 6. Do you agree with that? That would give me the same thing, 3, 5 pi 6. Or even 3 and then negative 7 pi 6. I would have ended up at the same spot, right? And since I did 3, negative pi 6, so I ended up here to pass through the pole, I could have done negative 3, 11 pi 6, and then pass through the pole. So there's other ways to get there, right? So when I plot this point, there's only one possibility for me to plot this point, but there's actually an infinite amount of ordered pairs that would give me that point because I could keep rotating around the circle. Where on the rectangular coordinate plane, if I plot a point, there's only one ordered pair you can give me, and it's also only going to give me 1 point. It's more specific. Okay, because we're going to have to come up with other points that match this here. Here's how this is going to work. Any questions before we move on? All right. So when we want to name them, it says while each pair of polar coordinates plots a unique point, each point does not have unique coordinates. Okay, because again, the coordinates, there's an infinite amount of them. In general, a point with polar coordinates r theta can be represented by r theta plus or minus 2 pi n, or negative r, comma, theta plus or minus 2n plus 1 times pi. Now, those are algebraically what it is. You could just plug numbers in and it is what it is. But I don't want you just randomly plugging numbers into things and having no clue why you're actually doing it. So we're going to come up with these points. We're not actually going to use that because I'd rather you be able to reason through it. But that would give me an infinite amount of answers if I wanted to do it that way. So this says to name 3 different pairs of polar coordinates that also name the given point if theta is between negative 2 pi and 2 pi. So we're only going to rotate once positive and once negative. We're not going to give an infinite amount of answers. So that means that there's going to be a total of 4 ordered pairs that would give me the same point. So they gave me 1. I'm going to have to give the other 3. Okay, so when you go to give your 3 points, 2 of them will have a positive radius, 2 of them will have a negative radius. This is a positive 2, so I'm going to need another positive 2, and then I need 2 negative 2s. Make sense? So I would just go ahead and fill that in, and then we'll go back and worry about the angles. So we're going to use the graph at the top to actually graph this one, but you're not going to need a graph every single time. And I made the graph a little big, so I have to keep scrolling back and forth, sorry. But we're going to plot the original one, 2 5 pi thirds. So I'm going to go to 2. I'm going to rotate around to 5 pi thirds, which is right here. So here's my point. So remember, when your radius is negative, you're passing through the pole. So I always plot the point, and then I'm going to draw like a dotted line through my graph so I know where it goes. I always use the point as obviously the actual point, but then I'm going to put a star where the negative radius should land. Because remember, if I have a negative radius, I have to land on the opposite side of the circle so I can push through to the other side. So my original one is 2 5 pi thirds. So go to 2 5 pi thirds. The first one I wrote down was a positive 2. So to use that positive radius again and get directly there, I would have to go this direction, which would be a negative pi thirds. Does that make sense? It's another ordered pair that gets me right there. So my first one's going to be negative pi thirds. If my radius is negative, my angle has to actually land me right here. So this angle is 2 pi thirds, so this would be 2 pi thirds. But if it was a negative 2, once I got there, I'd have to push through to the other side. So since I have a negative 2, this would be 2 pi thirds. The other way to get here, instead of going a positive 2 pi thirds, would be to go a negative how much? Think about how many quadrants you go through. So I'm here, I go through 1, 2, third quadrant. So my third quadrant pi thirds angle would be 4 pi thirds. Because you're not in that quadrant and it's negative. Okay. What questions do you have? Do you understand how I came up with those? Drawing yourself a little picture is going to help a lot, but you're not going to need a ton of those graphs. I wanted to do it on one graph because I was afraid my little side pictures don't always do them justice. So here's what I do, what I would do on these when I'm not given a graph to use. I would draw myself a little picture. Okay, so here's my circle. There's my pole, right? So this, I'm going to plot this point, just kind of sketching it. It doesn't have to be perfect. It's negative 5, negative 7 pi fourths. So 7 pi fourths, if it was positive, would be in the fourth quadrant. So when it's negative, I'm actually in the first quadrant. But my radius is negative, so I have to push through, and I actually end up over here in the third quadrant. You with me? Just kind of putting an estimate about where it is. As long as I'm in the correct quadrant, if it's perfect, it doesn't matter. But that's this point right here. So then I'm going to draw myself a little line through here, put a star over here, because that's where my negative angle answers will have to land. Just like it did, because I landed on negative 7 pi fourths, and then I had to push through to the other side. I know I'm going to have 3 answers. So this is a negative radius. I need another negative radius, and then I'm going to have 2 positive ones. So to land here, I went negative 7 pi fourths. I could also land here, and it would be a positive what? Pi fourths. And then I need a negative radius to end up over here, so that goes with my negative radius. That's my pi fourths. Okay. So I've taken care of both negative radii. So now I want to know how to directly get here. Well, that's in the third quadrant. If it's a positive radius, what's my third quadrant pi fourths angle? 5 pi fourths, right? To get here, I go negative. I would end up 2 quadrants over. My second quadrant pi fourths angle is 3 pi fourths. That would be a negative 3 pi fourths. What questions do you have? Any questions about how we figured any of that out? We're all good? Okay, here's one thing I want you to notice about the angles. If we think about the absolute value of the angles, notice that I have pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths. So you're using one from each quadrant. So if you use 3 pi fourths twice, whether it's positive or negative, you did something wrong, because it won't make any sense. It won't get you in the right spot, okay? The other thing is, your assignment's in Delta Math, and part of the instructions, because it was some questions I had to create, it says to enter your answers with your y values, not your y values, your theta values from least to greatest. So I would just write them down just like we did. You find them in whatever order makes sense to you, but then go back and maybe label them. So like if we look at number 7, if my theta values have to go in from least to greatest, then this would be the first ordered pair I'd have to put in because it has the smallest angle. Then this is the next smallest angle, so this would be the second one, and then this would be the third one that I have to enter as my answer, okay? I had to do that because I couldn't there's no way for me to say, hey, take this answer or this answer or this answer. So just write all 3 ordered pairs down, and then make sure the ordered pairs go in with your y values or your theta values from least to greatest. Does that make sense? So that means here, the first one I would put in would be this one, then this one, and then this one. And it's got to be a total coincidence that they're actually in the same order. It's just a weird thing that happened. Okay. All right, so I want you to try number 9 on your own. Give you a minute to get that done. Have I given you enough time? Maybe. Okay, so here's where the point ends up, because if I go to pi sixth and it's a negative 1.5, I end up over here. So that's where my negative radius has to land me so I can push through, right? So here's my other negative radius. Instead of going a positive pi sixth to get there, I can go negative 11 pi sixths, and then that negative 1.5 puts me over here. So this is negative 11 pi sixths. If I want to get directly here, I'm in the third quadrant, so my third quadrant pi sixth angle is 7 pi sixths. And then also to get directly here, I can go a negative, that would take me through 2 quadrants, so that would mean that's a negative 5 pi sixths. Okay. What questions do you have? Anything? We're all good? Getting back in the swing of things? All right. On number 9, what order we would put them in delta math, right? The smallest one, this order pair would go in first, then this one, right? So I wouldn't try and find them in the order from least to greatest. I would just find them and then make sure that you actually write them down and then number them.